Chapter 9, Features of C# 2.0. In this chapter we're going to continue taking a look at generics. So in this lesson we'll take a closer look at what generics are, how they work, the rationale behind them. Specifically, we'll talk about generics, the term, why use generics, how we create them, how we can define generic classes and fine-tune generics to be used in methods where necessary. Essentially, generics allow you to write code that can work with a specific type. They are useful because they provide stronger compile time type checking than was available in the previous system.collections namespace, since that dealt with the type object, so it did not distinguish at compile time if the right type had been stored in the list or collection. The other benefit of generics is they require fewer explicit conversions between data types. If I'm storing everything as type object, then I've got to cast it back to my specific type. There's boxing and unboxing going on. If I'm storing the thing right at the beginning as the specific type, i.e. integer or string or customer, then I'm reducing boxing operations and runtime type checking, so my code is going to perform better. We're kind of giving the game away here as to why I choose generics. So really, what I just said before applies here. Without generics, general purpose data structures can use type object to store the data of any type. This is good when you want to throw things into a general bag of bits, if you want to think of a general container. However, it's bad when you want to avoid the wrong thing being stored in a specific container. If I'm building a list and it should only store information about books by storing book objects, and I throw in a string or an integer here and there, that's going to be not what I want, and that's going to cause my program to have an error or give an unexpected result. Creating and using generics is done as follows. Generics allow you to specify type parameters. So you can think of these as placeholders for where you will specify the type later on. Here's an example of a generic class. So I'm working with the stack class that you may already be familiar with from .NET 1.1 in the system.collections namespace. Now, in the system.collections.generics namespace, I'm declaring a class, stack, and in the angle brackets I'm putting T for type. It's a placeholder for whatever type that I want. The rest of the class is pretty similar to the existing stack class in the framework. So I've got my array of items, I've got my counter, I've got the push and the pop method. Each of them is working with the type. And at compile time, then I can specify that this stack class should only work with, let's say, integers or strings or a custom type. So when I get around to using the class, I substitute the actual data type. So I declare my stack, angle brackets int, stack equals new stack, angle brackets int, and then I call the push method, push an int onto there, and I pop off the stack, and it's a beautiful thing. I don't have to do any conversions. It automatically stores or gives me the result back as an integer, and I can store that in my int x variable. So essentially, long story short, I'm substituting the angle brackets t, the type, with a specific data type, namely an integer. Once you understand this idea, it's really quite powerful, because this means you can build classes that are generic, hence that word generic, that will do whatever you want them to do, in this case, work with the stack. But you can substitute, when you want to, at compile time, the very specific data type you want to work with. Nothing else will go in there. Compile time errors will be caught in the designer by Visual Studio, avoiding problems at runtime. Much, much better. sometimes you don't want to make the whole class generic. You only want to make a portion of the class, namely a method. So you're passing in a parameter. You want that method to be fairly generic so you can pass in the appropriate type as needs be. So you could do that also. We'll see an example of this a little bit later. So to summarize, we took a quick look at what generics are, why we should bother with generics. I think we made a good case for that. Creating generics, relatively straightforward. Notation may be a little unfamiliar with the angle brackets, but you'll get used to it relatively quickly. You can build generics at the class level. The entire class works with generics, or you can specify just a single method or several methods that take in a generic parameter. And in the upcoming demo, we'll examine this in a little more detail by building a sample for you to take a look at. Okay, thank you.
Thank you for viewing the video. Because of the video size limitation, we cannot post the complete video. Please visit www.learningdom.com to view the remaining video. Thank you.